Jam. Welcome everyone to yet another First Flight. Today we have another interesting project. Remember, First Flights are our efforts to bring more auditors to the competitive audit space by giving you test projects for you to practice, earn experience, and hone up your skills as auditors. On this occasion, we have a different version of a first slide we already had before, and this is all about account and wallet abstraction. So actually, let me share my screen and let's get started. Also, we are featuring the new interface for Codehawks. As you can see, we have a complete redesign on the platform, and I'm going to show you everything you need to know about this first flight as well. First flight number 19, Mondrian Wallet version 2. We already hosted, as I already said, another competition, another first flight about wallet and account abstraction on Updraft, on Codehouse, sorry, but that was for Ethereum-based wallets. Today, we are bringing the same exact concept, but for zkSync chain, and it has its own differences. So before we get started and I start explaining everything here, please be sure to open the GitHub repo, clone this into your machine, and have it ready to start this explanation as I already have here on my computer. So basically, for those of you who doesn't know what account abstraction is, I highly recommend you to take a look to Patrick Collins' video. He actually published this like 2 days ago. You can check it on Patrick Collins' YouTube channel. Let me actually make this big for you to see. What is account abstraction or ERC 4337? This is a really nice explanatory video for those of you who haven't touched account abstraction before, but let me give you a small explanation about what account abstraction is. So let me go back to my browser over here, and I have prepared a small presentation / diagram here. So basically, when you want to make something with account abstraction, you want people to be able to interact with the blockchain without them to necessarily having to manage private keys, wallets, etc., etc. So basically, the user signs the data they want to send to the transaction. We have something called the alt memory or memory pool nodes. These memory pools send the information to Ethereum. You always have a smart contract acting as the entry point, which validates the information sent from this point. And well, from this entry point, you can always have plugins like a master payment.sol, but that's another story. Once the information is processed, the information is sent to another smart contract, which is the account, because yes, on account abstraction, smart contracts acts as wallets. And then after all this process finishes, the transaction is actually recorded on the blocks on the blockchain. As I said, this competition is for zkSync, and the big differentiation between this standard, which is the ERC 4337 on Ethereum, and zkSync is that instead of having an alternative mempool off-chain, the account or the wallet inside zkSync has both the wallet and the alternative mempool. So basically, any wallet created on the zkSync chain is as well a smart contract. So you have like one skipped step. As zkSync has wallet abstraction built in, we don't have to have a lot of configuration beforehand, but instead using what zkSync already provides. That's why you are going to notice that the scope of these smart contracts is actually just one smart contract called Mondrian Wallet 2. And the reason is because this smart contract is importing a lot from the pre-built zkSync stuff. Of course, we put a lot of bugs, security issues, and vulnerabilities on this smart contract for you to be able to understand um, on a deep level how a con abstraction works, and of course to hone up your skills as an auditor. Again, I just made really a small and basic presentation about what is the concept behind a construction and the differentiation between Ethereum and zkSync, but I highly recommend you to go to Patrick Collins' video. Actually, I'm going to pin this on the comments here. Let me copy this correctly. Okay, okay, and put this on the comment section. This video is going to give you a basic understanding on account abstraction. And if you want to have a deep dive in guide, you have two options. Go again to Patrick Collins' channel, and you have its latest video, Account Abstraction Ultimate Tutorial. This is a 4 hours long tutorial for you to actually code and understand account abstraction. Though this exact same information is already existing also on Cypher Updraft. And for those of you who are taking the new sections on Updraft for zkSync, you are going to find this really useful. As I said, I'm getting for granted that you already cloned this repo on your machine. And of course, the first thing we need to do always is to do a make install. I already have this. So let's use a make build. I'm going to have a small problem over here, as you are going to see right now. And for those of you using Mac OS, this is important for you to know. If you are using the fork for zkSync for Foundry, you are going to see that this is refusing to compile. And the reason is because we have some missing library. So you are going to install it using brew or homebrew, brew install lib usb. For those of you who encounter this problem, this is the solution. So if I use make build again, this is going to compile the contracts without problems using the zkSync fork. Also, as we are not using plain Foundry over here, I highly recommend you to go to the contest documentation on the getting started, because here you are going to find the link for Foundry zkSync. As we are using zkSync blockchain, we are going to need to use this fork. Installing this is actually pretty easy. You just need to go to the quick install, clone the repo, cd into the folder, and use the installation script. This is going to allow you to install that zkSync fork for you. Once we have this, as you can see, the smart contracts compiled without errors. We have a lot of warnings over here. This might be your first entry point to see what vulnerabilities this smart contract has. And of course, as we are not using technically ERC 4437, but instead using the version created for zkSync, don't forget to also go to zkSync official documentation. And here you have all the information about account abstractions they provide. So learning how this works, especially on the design section, because you're going to see all the interfaces they use for this, is going to be really useful. Additionally, other thing you need to understand to be able to audit successful this project is upgradable smart contracts, or the UUPS pattern. For that, don't forget to also check our article on the Cypher blog about upgradable smart contracts and the proxy pattern that I'm going to actually also pin on the comment section. Once you have checked all the documentation from zkSync about account abstraction, you understand what upgradable smart contracts are, and of course, you have the basic understanding on how deploy to zkSync and using Foundry with zkSync, you're going to be ready to start checking the code for this first flight. For those of you who haven't used Foundry before, or Foundry slash zkSync, we recently updated all the courses on Cypher Updraft to be able to run and work on zkSync. So if you want to learn how to deploy on zkSync change, please be sure to also check Cypher Updraft because all the courses are updated here. Now, let me go back to the Visual Studio Code and let me show you the actual smart contract. So here we have, as you can see, it's actually a small smart contract, just 168 lines of code. And the reason is because, again, as this is importing from this pre-built zkSync, we have a lot of imports. And of course, we have the Open Zeppelin upgradable smart contracts pattern. We have standard functions for wallet abstraction here, plus validated transactions, executed transactions. Remember that this validator of the transactions usually happens on this section of the process. Let me go to the Scali draw on the entry point dot sol. Pay for transactions, prepare paymaster. This plugin or paymaster actually interacts with this entry point. I haven't added that to this diagram, but yes, the entry point interacts for the paymaster. Is the responsible for actually paying the transaction to be able to be added to the blockchain. Also, the mempool pays the gas to be able to send the information on the signed data. And of course, we always recommend you to use the solidity metrics extension for you to understand what are the intricates of this project. So basically, you go to the smart contract, right click, solidity metrics, and this is going to give you this interesting report in which you are going to have all the information of all the dependencies and libraries this smart contract is importing from, and of course, the inheritance graph. But actually, let me show this again. I don't know why it's missing. Okay, sorry, let me open this again. Somehow it's missing. Okay, here we have. So Mondrian Wallet v2 inherits from the interface accounts. This is from the zkSync internal integration for account extraction. This contract is initiatable, and it has this ownable upgradable and the UUPS upgradable smart contract pattern. Of course, one of the things you need to take in consideration here is to check all the tests, be sure all the functions are tested for this smart contract. And one of the things you might need to be aware of for this type of smart contract, as the scope is not that big, is how we can make this smart contract perform something that the smart contract is not supposed to do. For example, signing a transaction and be able to surpass the controls the entry point.sol should make someone to be able to sign a transaction without paying the gas, and a lot more stuff. So let me summarize all what I said here. This is the second version of a wallet abstraction or account abstraction we are launching for a first flight. The first one was for Ethereum that works in this way using the ERC 4337 standard. And now we are launching the same concept, but for the zkSync change that has its own difference. Especially, again, please take a look to the zkSync documentation for account abstraction. This is going to be really useful for you to understand how this works. Don't forget to take a look, to upgradable smart contracts and the smart contract proxy pattern. And of course, we hope you to find a lot of bugs and errors and submit that to the contest page. That was it on my end for this first flight kickoff. I hope you get the most out of it. And again, for those of you who haven't used zkSync before, don't forget that we have upgraded all the curriculum on Cypher Updraft. And right now, we have all the information needed on how to deploy and build for that blockchain. Thanks for being with me on this kickoff. Remember, our community manage community manager, Ekios, is always on Discord ready to help you if you have further questions. And I'll see you on the next first bite. See ya.